everyone. I hope you all can see me and hear me. My name is Prima, and I'm going to talk about how we automated ourselves out of the response rut in a few seconds here. I don't know why my slides are set at Q&A. So let's go to the beginning. Okay, we are going to talk about how we automated ourselves out of on-call burnout, and you all can too. So, a little bit about myself. I am an information security professional. I've been working in the security space across various industries for the last 10 years or so now. And some of the industries I've worked in include oil and gas, very traditional, absolutely not code related technical at all, technical in other ways though. And then the music streaming app, that was Pandora, fintech, and been working in tech industry in the Bay Area ever since around 2015. So let's get started. I don't know how many of you are aware or familiar with what a week in the life of SIRT on call looks like, but I can give you a small sneak peek of what that looks like. So, SIRT stands for Security Incident Response Team. And a lot of the things that we do tend to be very repetitive or mundane. Repetitive in the sense that they get very, a lot of the alerts that fire take the same type of responses in the same way over and over and over again. And it gets mundane because it gets repetitive in some ways, because once you know how to respond to a particular alert, it becomes like muscle memory almost. And then, half the time you can sleep your way through response, and that is dangerous because that's what makes a lot of this response tasks error prone. So that is a huge security risk, because what then happens is you've zoned out so much, or you're spaced out so much while you are trying to respond to certain alerts. You are expecting certain behaviors. You have all these preconceived notions from having responded to it historically, that you start your brain starts tricking you into believing that this is just one more of the same false positive that you resolved yesterday. And in fact, that might sometimes not be the case. And when that isn't the case, guess what happens? An incident that potentially gets missed, or an incident that doesn't get detected soon enough, which could have been detected soon enough, and so on and so forth. And that is not good. That impacts the security posture of the entire company. It also impacts the SIRT team's morale, because the SIRT team has to be able to, defend the company against all kinds of attacks all the time, whereas the attackers have to win only once. So even that one miss on the SIRT team side can potentially bring the morale down by a lot. And that is also not good for the team's mental health and well-being in general, right? So the state that we were in, the state that I was telling you about, looked a little bit like this before we made the changes that we did. So the state was such that we would receive an alert that would say third-party access detected in account blah. And then an engineer would actually take a look at all the indicators, would do any of the further searches that they may need to do on the basis of different indicators. And then they'd have to comment and say, this is the account with this name. So, for example, the account ID appears in the indicators list, but we don't know what the account name is like. So then they'd have to take that account ID, open a new tab, enter that account ID there, search, perform a search, and hopefully find the account name if the account exists. Then, copy that name again, come back to this same dashboard and put it in the comment and annotate it. And then, they'd have to keep doing that, keep opening different tabs in order to check different types of things, and keep copying and pasting things. And that gets tedious. That's, even if you think that's like 30 seconds a tab, there are some alerts that require opening as many as 5 tabs or 6 tabs in order to perform searches in different places. And just figure how much time that is, right? That's a lot of time. But What we realized was that repetition is almost always an opportunity for automation. So anything that is perfectly repeatable and the team is doing it over and over again, that's good news. That's great news because this that indicates that the team can basically, automate it away and machines can take care of it for them, right? So that's what we realized, and what we built looked something like this. So when the same type of alert fired after we built what we built, it said things like third party access detected in account blah. Then the machines would go and say an actor from this account performed this action on this resource and this account ID. And the actor's account ID is in AWS with this name. It auto performed that search for us, and it told us as much. It even annotated everything for us, so we don't even have to copy paste anymore. And all we have to do then is make that final decision and that final call about what and whether or not this is false positive, depending on all the data that the machines have already collected and annotated for us. How great is that? That is definitely very effective. And how much time do you think this saves us, right? So take a guess here. I'll give you all a couple of seconds. This brought our MTTR, meaning mean time to response, down by about 40%. So, our engineers were spending half the time or lesser on every alert after we implemented the solution. And on an average, it saves us about 5 to 10 minutes per alert on approximately 35 alerts per week. That is a lot of time. That is a few hours of an engineer's time during their on-call cycle, and that's the time that they can potentially spend towards their project work now, versus having to spend on ad hoc response tasks like this one. So then how long do you think this took us to implement, right? Take a couple of seconds here as well, and I'll show you how long it took us to implement. This took about 6 months of one full-time engineer's time. And while I was building this and implementing this, I was also actively involved in a bunch of other ad hoc tasks, regularly being on call. It's not like this was the only thing I was doing. I was doing 10 other things along with this, and still it took us only about 6 months, which is 2 quarters. That's not bad at all for the amount of time that it saves you once you've implemented it, right? It's like a gift that keeps giving, basically. And all the further improvements that we've been able to do on it, I'll be able to show you that later in the track as well. But let's not jump the ship, and let's first find out what the solution was like and how can you do it as well in your environment. So how did we do it? We took an open source tool called Sockless that was originally created by the Seconds team at Twilio. We customized it to fit Segment's infrastructure and security need. However, funny thing, Segment got acquired by Twilio. So now we are also a part of Twilio. However, a lot of the Segment infrastructure does run, especially this automation infrastructure, does still run independently. So all that work that we put into customizing it and everything, well worth it. We also built a CI/CD for it and made it super production ready. And by we, I mean Twilio's Segment security team. And then let's talk a little bit about Sockless, what Sockless is all about, right, as a tool. So Sockless is AWS native. Every task is a Lambda function, and all the Lambdas are then tied together to create a runbook inside the step functions. So every playbook is essentially a state machine, and this is roughly what it looks like. So an alert from its source hits the AWS's API gateway, and then depending on so the API gateway gets hit, and then it auto forwards it to the event endpoint Lambda. There, depending on what the runbook name is and which part of the runbooks we want to kick off, that's the endpoint that then routes it to the appropriate step function. which then kicks off the runbooks, the lambdas inside that runbook. And that's how the entire architecture is set. It is very beautiful and very elegant in the way it's been created. Very simple, and it does the job just right in our experience. So, what the runbooks look like in real time, your step functions look something like this, where it says, every step. So, for example, where it says check CB approved list is hash in approved list, and so on. Those are all different steps inside that runbook, and every step is essentially either a choice state or a lambda function that runs and grabs some kind of an information. So I'll show you one very important thing here. Everywhere that you see update Jira, anything that starts with update Jira, blah, that is essentially the exact same lambda function running with different types of comments to update Jira. So what that means is that once you build an integration, once you build a lambda function to do something, that same function can then be reused many, many, many times across all your playbooks. And that way you don't have to reinvent the wheel ever again. All you have to do is then, provide it the specific input for that particular step, and it'll do it accordingly. And that way, what happens is once you start building all the integrations, so the very first run book that you build integrations for, it'll probably take hours because you are trying to build every integration for every step it does. But then as you move forward in the runbook automation creation process, you will find that more and more there are all these pre-existing lambdas that you can just literally reuse and plug and play. So the amount of time it will take you to build a particular and automate a particular runbook will keep going down and down and down, and that's the beauty of it. Build once, use many times, use within the same runbook many times, use across runbooks many times as well. It's fully modular, and I find that to be very cool. It's particularly useful around things like Slack integrations, because there are so many alerts where you may need to follow up something or gather information from a individual in your Slack organization, and all you have to do then is build that integration once, and then depending on what different inputs are in different playbooks, it'll ping that person automatically and collect responses from them. So now moving into the customizations part, remember how I told you all about how we built it to our needs at Segment? So let me show you what were some of those customizations all about. So in the default sockless settings, dev, stage, and prod were in the same account, but in separate regions. And you can still see that in sockless's, repo on GitHub, the open source one. Dev, stage, and prod are in the same AWS account, but in separate regions. How we built it at Segment was all dev, stage, and prod were all in separate AWS accounts completely. To provide for that, full segregation and separation. We have alert at Segment. We have alert error monitoring and alerting using Datadog and Slack. So whenever a Lambda goes down, for example, we want to be able to know it immediately, especially in production. And we build that ourselves. And then we've also built the CI/CD for sockless deployment and integration ourselves. So that, of course, doesn't come with the open source. That would be virtually impossible to build it to fit every company's needs. Then AWS default URL is used for API gateway in the default open source implementation. But Segment's implementation, we have a custom API, a gateway URL on a custom domain, and so on. We also have a different, more narrowly scoped default Lambda execution role that we use. We found that the open source role was a little too broad for our liking, so we narrowed it right down to suit exactly just what we need. We also added log retention duration to be 30 days in CloudWatch, because otherwise the Lambdas can keep collecting logs and they can pile over years. So we did not want that, and we set a 30-day log retention duration, because we haven't come across a scenario in which we would have to go beyond those 30 days ever. And then secret handling is done differently in both the default settings and the custom that we built for Segment. And you can come and ask me more about it later if you have more interest in knowing more about what this is all about and how we've built it at Segment versus how it is by default in the open source. So speaking of talking to me and asking me what everything is all about, how do you do that? How do you even start? What you do is you start with the Sockless Getting Started tutorial. Sockless also has a beautiful community Slack workspace. Everybody is super responsive, especially Ubani and Saxon. And I'm now also very active in the Slack workspace as well. And you can always come and say hello to us. You can find us there in the Slack workspace. The link to the Slack workspace is in the Getting Started tutorial. You should be able to find it with a lot of ease. And then also, once you've started with the Getting Started tutorial and started doing a bunch of basic things, what you'll find out very quickly is that you will find yourself reading through the serverless framework docs a lot, because Sockless is built on top of serverless framework. And those docs are super useful, especially if you want to customize things the way we did. If you get to know how serverless works, that makes the entire building process and improving process just that much easier. So I highly recommend reading through these docs as much as possible as well. And last but not the least, questions and answers time. Please let me know if you have any questions for me. Also, please know that Twilio is hiring across the board, all the way from the junior engineers all the way up to director level. We have so many recs open at the moment, and please feel free to check it out on our careers page. Please feel free to reach out to me if you're interested in any of those recs. And when I say across the board, I also mean in all kinds of vertical security pillars as well. We are hiring in SIRT, we are hiring in ProdSec, we are hiring in AppSec, we are hiring basically across the board, vertically and horizontally. So please reach out. We also have a booth here at Day of Security, so feel free to go and speak to some of my colleagues. They are some of the friendliest people I've ever worked with, and they'd be more than happy to talk to you. I'm also happy to for you to reach out to me on Twitter. My handle is SecNerdette, and on LinkedIn, I'm there as Prima Virani. You can find me in both those places. And let me open the stage for questions that you may have. I am now looking at the questions. Thank you for organizing this Day of Security crew. Thank you, Megan. Thank you, Kelly. Thank you so much. Okay, looks like there are no more questions. I'll be hanging out in the Day of Security community Slack as well, and also in the Sockless community Slack. Feel free to reach out to me anywhere, and I'm more than happy to answer and talk to you all.